This problem is about bond energy defined in Chapter 9. Take a few minutes to read the problem, propose a plan to solve the problem, work on the solution, and compare your answer after a few minutes. To solve this problem, the main concept here is to associate the energy of a photon with the energy of a bond. We are going to use Avogadro's number to calculate the energy of an OH bond per molecule. This will be the minimal energy needed to free up an hydrogen atom from water. For the second part, which is calculating the frequency, we are going to use the formula that relates energy to frequency, E equals h nu, to solve for the frequency of the photon. So let's begin. So the energy of a photon can be calculated then as 467 kilojoules per mole, and this corresponds to an OH bond. And then we take into account Avogadro's number, that 1 mole corresponds to 6.022 times 10 to the 23 photons. And this corresponds to 7.755 times 10 to the minus 22 kilojoules per photon. We can round this up to 7.75 times 10 to the minus 22 kilojoules per photon. So the second component refers to the frequency. For frequency, we know that E equals h nu, which implies that nu is going to be equal to energy divided by h. So we can explicitly solve this by saying the same as before, 467 kilojoules per mole. We have 10 to the third joules per kilojoule, and then we are going to take 1 mole equivalent to 6.022 times 10 to the 23 molecules. And then we are going to divide all of this by h, which is 6.626 times 10 to the minus 34 joules second. If we solve for that, the answer is 1.17 times 10 to the 15th seconds to the minus 1. Just make sure the dimensions are correct. Mole, mole, kilojoules, kilojoules, joules and joules, remaining only seconds. So that corresponds to the frequency of a photon that is required to release a hydrogen atom from water.